Ahoy and welcome. My name is Chief Mate Clemens Helm and you're watching Codeship Testing Tuesday number 10. Last week we specified single components of our application using stubbing and mocking. We stub behavior of other components to become independent of their implementation. This week I will show you how to stub code that doesn't even exist yet. This will improve the way you design your code. We'll keep working with last week's application. We've got a user with a first name, a last name and a full name. And the user has many projects. And we've got projects that have a name. But right now every visitor of our application can access all projects, but we'd like only team members to access their own projects. And as usual we write a cucumber feature first. So our feature is restricting project access. In order to keep a project private as the project's owner, I only want team members to access the project. And our first scenario is accessing a project that I'm not team member of. So given I'm signed up as no submitting attendee, when I try to access another user's project, then I should not see the project. And these are our step definitions. We reuse the first step from last week's example, which is given I'm signed up as username. And what we do is we split the username into first name and last name, fill first and last name into the sign up form, and click the sign up button. And the two new steps are at the bottom here. When I try to access another user's project, so we create another user, create a project for this user and visit the project's path. And then I should not see the project, which just compares if the current path is the project path. When we run this feature, it fails because so far we haven't got any restrictions what should be accessible or not. So actually we are at the project path in the end. Let's write an example for our project controller to prevent access. So I'll just paste the example in here. It should check if a user is a team member. So we've got a user, which is a double, and a project, which is a mock of the model project. We use mock model here, so we have a project ID here for calling the controller. We also simulate that there is a logged in user by stubbing the current user method on any instance of the project's controller. We use this approach because the instance of the project's controller will be automatically created for us by calling the controller action down here. But what's really nice is that we can use our example to specify the code we wish we had. So far our user model doesn't have a method member of. But it would read nicely, so I decided that a user should have this method. So let's make this example work. Let's run this example in RSpec. And it failed because it expected member of to be called on the user one time, but it never happened. So let's make this example work. And the project controller, in the show action, we need to add current user, member of the project. Like this. And when we run RSpec again now, it works. But in fact, this doesn't really change the action's behavior. What we want is to redirect users to another page if they aren't team members of the project. So let's add another example for this. I'm just going to paste this example in here again. It should redirect non-team members to their project's overview. So we've got a user who isn't a member of anything. We've got our project again. And the user is also our current user. We stop the find method on the project like above. And when we call our controller action, we expect our response to redirect us to the project path. Let's call RSpec and see if it works. And as expected, it failed because it expected a redirect, but it got 200, which was actually the project's page. Let's fix this. In the project controller, we can just write redirect to project's path. And this will make our example work. But this is still not what we desire because we only want to redirect if the user is not member of the project. So actually we need another example now. But before we do this, let's clean up our examples first. Like application code, you should also refactor your examples to avoid repetition and keep them clean. Consider refactoring your examples every time you made them pass, but refrain from refactoring when there are still failing examples. This will make everything much worse. Trust me, I've been there. Let's move all our duplication into a before each block. This will be executed before each example. Before each do, and in here we can put the user, the project. We can also put the stub on the user in here. Doesn't really matter. We can move this stubbing in there. And that was about it. Let's remove these duplicated lines also down here. But now we can't access our project and user anymore in the examples because they're local variables, but we can get around this by making them instance variables. We just have to take care to correct them everywhere they occur. Okay. I think this was it. Let's run RSpec again. And it still works. Our refactoring was successful. So also our next examples will probably be shorter. I'm still gonna paste the next example in here because I'm lazy. So it should show the project to team members. We've got a user who is a team member. We call our controller action and it should respond with the show template, which shows us the project. Let's run RSpec for this. And it fails because it expected show to be rendered, but actually there was nothing rendered. But we can fix this by adding the condition to the project's controller. So we can say unless this happens, we want it to redirect to the project's path. If we run RSpec again now, everything works. So we've got a perfectly readable controller action by specifying code that doesn't exist yet. I like this method of designing a component's interface because usually it's much easier to specify simple code than complicated code. So when you stick to this pattern, your code will become more readable and more structured automatically. But where do we go from here? Well, we've specified everything we need from our controller, so let's run our scenario again. It fails, telling us that there is no method member of for a user. So our scenarios are always the safeguards that remind us to implement everything that's still missing to make our new feature work. So let's implement this method now. A user should be a member of a project when it has got a project membership. So I'll paste this example in here for our user model. So it should query a membership. We've got memberships, which is a double. We've got a user and the project, and we stop memberships on the user, and the memberships should receive where with the project ID. So it should find a membership for this project when we call user member of project. So when we run RSpec now, it tells us that there is no method member of for user. This is quite easy to fix. We make a method member of on user and run RSpec again. Okay, it also expects an argument, which is the project. Let's run it again. And now it tells us actually the memberships didn't receive where with the project ID. So let's also make this work. Memberships were project ID. And running RSpec again tells us that everything is okay. But now our method will return a database relation instead of true or false. So we need a second example. As usual, I paste it in. It should not be a member if no membership exists. So we've got a user again and a project, and we use stub chain. So this means if these methods are called in a row, then the last one should return false. And for this setup, the user shouldn't be a member of the project. When we run RSpec now, it fails because it expected false, but it got an RSpec mock that was created by our stub chain method here. The easiest way to make this method work is just by returning false. And now both of our examples will work, but that's still not what we want. So we need one more example, which is exactly the other way around. It should be a member if a membership exists. if a membership exists, and then we say it exists is true, and then also being a member should be true. So let's run RSpec again. It tells us the third example failed. And the only way to fix it is to go to the user model and call the exists method on our where clause. If we run RSpec now, it fails again. But now our first example failed because it doesn't know about a method exists. We can get around these errors by calling as null object on our doubles, which will cause any method called on the double to return the double itself. So this way we get around nil values. So let's run RSpec again, and this time everything succeeds. So let's run Cucumber again. It tells us that there's no method memberships for our user. So the only thing left to do is to create the membership relation between the user and the project. With Rails, we can create this relationship on the command line. I think I'm just gonna paste this in here again. So it created a database migration for us, a membership model, and also an RSpec file. Now we can migrate our database and prepare the test database as well. The only thing left to do is to tell the user that it also has many memberships now. And if we run Cucumber again now, everything works. The nice thing about this outside-in approach is that you define the methods you need first and take care of their implementation later. Without this approach, we would have probably started by creating the membership model, and then we would have written a controller action. But then the controller action would have probably looked like this. This action is much less readable than the one before. We deal with an abstract membership term instead of just asking if a user is a member of a project. And we increase complexity by having a long method chain with a database query in our controller action. But what's even worse, this code is not reusable, whereas our memberof method can be used many times throughout the application. Of course, you could also refactor this controller action and create the memberof method afterwards. But this would be an additional step, and these get forgotten quite often. With our outside-in approach, this code just evolved naturally out of our process. However, some of you told me that they don't like running the integration tests to verify that their stopped behavior still works because it slows them down. I tend to run only unit specs and the Cucumber feature I'm currently working on my local machine, like we did it now. Once I've completed a feature, I push it to GitHub and the Codeship will pick it up and run the entire feature suite for me. If something broke, it would inform me, so I can keep working while the Codeship checks my current code. I'm a big fan of having integration tests checking the entire system's behavior before I ship something. However, if you just want to verify that your mocked behavior actually works while you're developing a feature, this feedback cycle can be cumbersome. Especially when you've got an extensive integration test suite, getting feedback from your continuous integration system can take 20 minutes or more. Fortunately, there are tools that verify your mocked behavior faster. But that's enough for today. Thanks to Raphael and Cesar who suggested Bogus to solve this problem. We'll take a look at it next week. Thanks for watching, see you next Testing Tuesday, and please remember one thing, always, really always, stay shipping.